Hello, my name is Trisha Patel and this is the video presentation for Unit 9, Summative Presentation. So here we have Unit 9, which is combination of functions. So here I'm going to do topic 9.3, which is product of functions. So in here we see how we multiply two functions, which could be f and g. So this is more like f into g into x, which is equal to f of x into g of x. So in here I've picked out a question which is more like in a set format. So we're giving two functions f and g. So f of x is this solution, this set, and g of x is this set. So here we're going to see how we multiply these two. So these are not like simply multiplied. We cannot multiply this by this or anything. So in here what we do is we find similar x values and we multiply their y values. So in this case we see that the x value in the set f of x we have 0, and we have a similar one over here which has 0 as the x value, and we see that the y's in both these are different. So here what we do is we first write this down here. So this is equal to, we have our 0, and here what we do is we multiply the y values, which is 2 into -1. So this is basically how we multiply two sets. We just find out the common x value and then multiply the y value. So I'll do the rest. So here I've solved the rest of them. So as you see, we have the similar x value and we just multiply the y values here for all of them. So we further just solve this. We have f into g into x is equal to, we have 0, 2 times -1 will give us -2. We have 1 into 5 times -2, which gives us a -10. We have 2 and 7 into 3, which gives us a 21. And lastly we have a 3 and 2 into 5, which gives us 10. So this is the solution for f into x into f into g into x. So this is how we solve two set functions. Next we're going to see how we solve functions which are more like a linear function. So here we see we have two functions f and g, and we're going to see how we multiply them. So in this case, since we just have a one function like this, we're going to multiply them the way we multiply normal equations. So here we have x into g into x, which is going to be equal to this times this. So we have -4x minus 7 into 4x plus 7. So what we're going to do is we multiply this. So we're going to expand it first. We have -4x into 4x plus 7 minus 7 into 4x plus 7. So here we get a -16x squared. We have a -28x. Here we have -28x as well, and here we get a -49. So here we just solve it. We have -16x squared, and here we have a 56x, and here we have 49. So what we're left with here is a quadratic equation. So if we try to factorize this, we solve it quadratically, we go back to this equation as well, and if we want to find the x value, we can further solve the quadratic equation to get the x value. So here we're going to find the domain of fx, which is negative 4 minus 7. So here we have the domain, which is going to be x. Since we see that this is more of in a linear form, so we do not have a denominator, therefore we don't have any restrictions. So this is, the values are going to be all values of x, given that x is greater than or equal to 0. Because if we have a negative, it really doesn't matter if you have a negative. So it could be any, but we could just write this down. It's not even really necessary actually. We could just remain with this. And similarly for g of x as well, the domain is going to be all values of x. We have no restrictions. It could be any value of x. And for f into g, the product of both the functions, which we got previously as negative 16x squared minus 56x minus 49. So here as well, it's a linear function, so we have no restrictions. So the domain of our product of the functions is also all values of x. So that's it for my Unit 9 presentation. Thank you.